want to mentally, if you want to mentally check out and keep studying your vessels and studying for lab exam 3, you can do that. And I gotta move my controls. Here we go. The Zoom controls are always in the way, it seems like. Okay, so the endocrine system. The endocrine system is basically dealing with glands that secrete chemical signals. And these chemical signals are called hormones. And a hormone is a lot like a neurotransmitter in that both of them are chemical signals. They're going to target a target cell, and the target cell is going to respond by basically changing its physiology. But a hormone is different from a neurotransmitter in that it's released into the bloodstream. And that means it can circulate throughout the entire body and can have multiple target cells. Unlike a neurotransmitter, which is released from a neuron and is directly released into the synaptic cleft, and the target cell is just on the other side of the synaptic cleft, there's close proximity. For hormones, the target cell may not be in close proximity at all from the gland that released it. So I will be comparing and contrasting the endocrine system versus the nervous system. I will also be going through quite a few endocrine glands, and I will also be teaching you a few axes. Our planet turns on its axis. So an axis is this linear line that seems to go through our orb, our planet, but an axis can also be a chain of command. And I am going to be telling you about a chain of command that starts with the hypothalamus, part of the brain that you're being tested on today. And the hypothalamus communicates to the pituitary gland, another part of the brain that you will be tested on today. And then the pituitary gland is going to communicate to some distant third endocrine gland. And I'm going to tell you the rules of those axes. And once you learn the rules for one particular axis, the same rules apply for other axes. And I guess I should just move on and hopefully you'll see what I mean as I start teaching you about these axes. So again, a hormone is a chemical signal that travels throughout your body in the bloodstream. It will have target cells. What makes a target cell a target cell? It has to have a receptor. Just like when the neurotransmitter was released into the neuromuscular junction, something you learned in lecture unit 1, skeletal muscle cells had a receptor for that acetylcholine. Same thing for a hormone. A target cell must have a receptor, and not just a receptor, it has to be functional, because if it's dysfunctional, then even if the hormone is released, the target cell can't respond to it because its receptor is broken. Some of you might have satellite dishes. Okay, your satellite dish is a receptor for wavelengths, signals coming from space. If your satellite dish is hit by lightning and is broken now, those signals from the satellites out in space are still sending signals down to Earth, but you're not receiving them anymore because your satellite dish is broken. Your receiver, your receptor is broken. And I can actually give you specific examples of people that release hormones but can't respond to them. And I'll point that out when I get to growth hormone, just to use that one as an example. A hormone can actually target many different cell types. I'll give you an example. Epinephrine is used both as a neurotransmitter and as a hormone. Epinephrine, when it is released into your bloodstream as a hormone, can target your heart. And the heart will behave to epinephrine as the heart should. Your heart rate goes up and the force of contraction goes up. So the heart behaves like the heart should. That's what I mean by each target cell will respond according to its pre-programmed way. Adipose tissue also responds to epinephrine. Adipose tissue, when epinephrine is around, releases a lot of the stored fatty acids. Adipose tissue doesn't act like a heart. So if a hormone targets many different target cells, you can see many effects in that person's body from that one hormone. And each of those target cells will behave how they're supposed to. Heart will behave like the heart. Adipose tissue will act like adipose tissue. The pancreas will act like the pancreas. That's what we mean by pre-programmed. Hormones can be triggered for release, stimulated for release in 3 different ways. Humeral means something in the blood. So humeral, something in the blood. By that I mean some sort of chemical, some sort of electrolyte, something that is naturally found in your plasma is being monitored. And if it goes too high or too low, that can stimulate a hormone to be released. I will give you examples as I keep going through this lecture. Neural, that means released. It's released like a neurotransmitter, but the neurotransmitter is dumped into the bloodstream. So then technically it becomes a hormone. And I will give you examples of that. And then hormonal means it's a chain of command, that axis that I was telling you about. And the axis always starts with the hypothalamus, and the pituitary is always the middle gland. And then there's going to be a third downstream gland. So hypothalamus is gland number 1, pituitary is gland number 2, and then some third gland will be after the pituitary, a chain of commands. These hormones are going to follow feedback mechanisms. Most of the time, our body is regulated using negative feedback. Negative feedback means, well, maybe I should explain some terminology. A term you should know is set point. And variable. Let's start with those two. A variable is anything in your body or produced from your body that I can measure. We're in medicine, we're always worried about variables. Heart rate is a variable. I can measure your heart rate. Your pulse rate, I can measure that. Your breathing rate, your body temperature, how much urine you produce in 24 hours, your red blood cell count, your white blood cell count, specifically the number of monocytes you have. Anything I can measure in your body or from your body is a variable. Your electrolytes, how much sodium you have, how much potassium, all of that, those are variables. When you go to the doctor and they do blood and urine analysis, you get pages and pages of data about all of these variables. And sometimes they're flagged, right? They're flagged as being too high or too low, which means all of those variables have a set point. And students, when they hear set point, they think it's one number that variable should be at, when really it's a range. I wish the early physiologists would have said normal range, but instead they use set point. Okay, it's not one number, it's a healthy normal range. For example, hematocrit. Hematocrit as an average is 45%. But women, their normal range is a little bit lower. It can be as low as 38%, and men can be as high as 48%. So there's a range. Body temperature, again, there's a range of acceptable body temperatures. There's a range for acceptable calcium levels. So set point is not just one number, it's a healthy range. Deviation means your variable goes beyond normal set point, beyond normal healthy range. That's when on your blood and urine analysis, they get flagged when you go too high or too low. That's a deviation beyond acceptable range. When a variable deviates beyond set point, beyond the acceptable range, then this will provoke a corrective mechanism. So feedback mechanisms are corrective mechanisms. For example, I am sitting in my kitchen area and we have every single window open. I'm very cold. I was sitting here getting cold during office hours. I started shivering. Not only did I start shivering, but as I was looking at myself on Zoom, I realized I was looking very pale. Well, when your body temperature gets too cold, your body starts to do corrective mechanisms, feedback mechanisms. Your blood vessels vasoconstrict and shunt blood away from your extremities, which is why when people are cold, they look very pale. Most of their blood is directed to their torso and abdominal region, to the core. Shivering is skeletal muscle that is having contractions, just fine contractions. When skeletal muscle contracts like that, it generates heat as a byproduct. So these corrective mechanisms are trying to conserve heat and generate heat to bring my body temperature back up toward normal. So I got too cold, corrective mechanisms bring me back up towards a normal body temperature. If I get too hot, then I start to have blood vessels that vasodilate and I look very flushed. And that's because now the blood is going to the surface of my body, not to the core, and it's going to the extremities so that I can dissipate this extra heat into the environment. And I start sweating. And when we sweat and the water on the surface of our skin evaporates, it takes a lot of heat with it. Those are corrective mechanisms. Specifically, negative feedback. Now, with negative feedback, shown up here, negative feedback means the deviation, I'll just put a D, and the correction go in opposite direction. So if I get too hot, my body wants to cool down. If I get too cold, my body warms up. That's what we mean by negative feedback. The deviation and the correction are in opposite direction. Most systems in your body use negative feedback as corrective mechanism. It is one of the healthiest ways to maintain your variables within their set point, their healthy range. But not all systems use negative feedback. A few use positive feedback. And the best example, they're showing here breastfeeding, but I'm going to use another one that goes with this, is labor and delivery, not just breastfeeding. Labor and delivery, breastfeeding, blood clotting. With positive feedback, the deviation and the correction go in the same direction. And students go, "Oh, then how is that correcting? If the variable is deviating away from set point and the correction takes the variable even further away from set point, how is that a corrective mechanism?" That's a good question. Let me say again, very few systems in your body use positive feedback because of the deviation and correction going in the same direction. Positive feedback mechanisms are used when your body needs to make a very quick, profound change. For example, most of the time your blood is in liquid form, isn't it? But when you cut yourself, you appreciate your liquid blood quickly transforming into this gelatinous substance we call a clot, because then that means you're not pouring out blood from that wound anymore. So clotting, we want a very quick change, like an avalanche type change. Transform liquid blood into this clot so we don't bleed out to death. Some people have clotting disorders, and that is a risk they have. They can, simple things like children losing a tooth and it starts bleeding, have died because they're hemophiliacs. They can't clot their blood. So that's one example. Let me go back to labor and delivery. When the fetus is near full term, I call the fetus a parasite. So when a woman is terminally pregnant, meaning she's almost to her due date, that fetus is really occupying a lot of the abdominal cavity. And the woman's viscera are shoved way up underneath her diaphragm. And that little parasite starts moving and they start stretching. Every woman out there in the audience who has ever been pregnant with a parasite knows they move and they stretch. And when they stretch, the uterus is smooth muscle. And one of the qualities of smooth muscle is when it's stretched, it contracts back. So here you have this fetus going, I need more space. And the uterus goes, oh, no. And when that uterus squeezes back, the baby's head is usually in a downward position at this point. The baby's head hits the woman's cervix. And the woman's cervix has neurons that basically go up to the woman's hypothalamus. So from her cervix, messages go up to her brain. And then her hypothalamus releases a hormone called oxytocin. And when that oxytocin is released, it causes even more uterine contractions. And as the uterus contracts even more, it makes the baby's head hit the cervix more, which sends more signals up to the brain, which leads to more oxytocin, which leads to more uterine contractions, which leads to more signals up to the brain, more leading to more deviation, correction, more leading to more. Until when? Until finally the cervix is dilated, the uterus is contracting with such force that now the baby is expelled, born, and then the stimulus isn't there anymore. So listen, all positive feedback mechanisms must ultimately be stopped with a negative. ultimately a negative feedback mechanism has to bring that variable back towards its set point. Otherwise, if that doesn't happen, the ultimate negative feedback is going to be death. Blood clotting. When you have a cut, you appreciate your blood going from liquid to a gelatinous clot, but you don't want the clotting to continue throughout your entire body. Then all of your blood supply would be this gelatinous form. How does it circulate then through your arteries and veins? It wouldn't. So something must stop that deviation, correction. It can't just keep climbing indefinitely. There has to be a negative feedback that comes in and says, right then, enough of that. Let's go back toward our set point. So with the baby being born, that's the negative feedback. Now there is no longer a head pressing on the woman's cervix. Baby's born. This picture from your textbook is showing you breastfeeding. Now, here's something that a lot of women don't know. When you are in labor and you get this oxytocin being released and your uterine contractions keep going up, it's painful. And a lot of women will get an epidural so that they don't feel that pain. And that's great. I highly recommend it. That way you just lay there, and when the doctor says, okay, it's time now to push, okay, I'll push. But what they don't tell you is when they send that parasite home with you and you decide to breastfeed, they don't tell you that, ladies, your breasts, like your cervix, are also wired up to your hypothalamus. And when that baby now starts suckling at your breast, that sends more signals to your hypothalamus and you release oxytocin all over again. And the oxytocin causes the glands in your breasts to compress, and then the milk comes out. So oxytocin doesn't make milk, but it causes the compression of the glands, and then you release the milk, which makes the baby start suckling even more. And as they keep suckling, it sends more action potentials up to your brain, and that leads to more oxytocin. Now, that doesn't sound too bad, does it? But were you paying attention when I said that a hormone can have many different targets? Oxytocin, you just heard me say, stimulates uterine contractions and stimulates the breast glands to contract. When you're breastfeeding at home and the baby starts suckling and this oxytocin starts being released, do you think it only goes to your breasts at that point? Nope. It will also go to your uterus. And I'm here to tell you, now you're at home trying to breastfeed your baby, and you will be having labor pains as if you hadn't birthed the baby yet, because your uterus is going to respond to that as well. And they don't send you home with an epidural. Yeah. It actually can be quite painful to breastfeed your baby, but not from the breasts, actually from having uterine contractions. They don't tell you that. I just did. Think twice. They don't tell you. Anyway, so be ready for that, ladies. It will take a while before your hormones actually start to not be so erratic with the swings. It eventually will be that when you breastfeed, you're not feeling those labor pains. Eventually, your brain learns how much oxytocin to release for breastfeeding.
It actually help your uterus go back to its size. Is that why it's doing that?
Not only that, but that's also why they frequently will put the baby to the breast as soon as it's born, basically, because that helps your uterus start to contract still. And that will reduce the amount of bleeding.
Oh, really?
Yep. Yep. And if you don't have the baby onto your breast right away, maybe because your baby had low APGAR scores and they're watching your baby, that's when the nurse and the doctor usually start pressing on your abdomen, trying to compress your uterus to basically uh, crimp your torn uterine arteries shut so that you're not bleeding as profusely. They're trying to get everything to clot. And that's fun. You should probably warn who's
Yeah,
ever.
nobody warned me about the abdomen press, and that was actually more
Hey,
painful than my natural labor. Like that was the worst part.
Yeah. Same here.
yeah, the nurses and doctors turn into like sumo wrestlers.
No,
Woo!
I had some muscular ones. It hurt.
Yeah. And they're trying to make sure that you don't bleed out because having that bleeding afterwards is the number one complication from birth, from childbirth. If they can't get you to stop bleeding and start clotting, women die of something called DIC, disseminated intravascular coagulation. And basically, when that baby is born and those uterine arteries are just basically ripped in half, there is so much bleeding. It's a lot of bleeding, as you all well know, and they're trying to stop it. And if they don't stop it, what happens is the woman can use up all of her clotting factors, and it's not enough to clot, and she just bleeds out to death. It is the number one complication that claims women's lives, is that DIC. So they take it seriously. Childbirth classes don't tell you about it. I certainly was shocked when all of a sudden I had like 2-3 people pressing on me, and it is uncomfortable. And then they stop for a while, don't they?
Come back like every hour.
And then they come back and they do it again. And then that's where I was about to say, you might want to warn who's ever in the room with you that that's going to happen, and to stay up at the north end, because as they push on you and you've been clotting, you turn into a human toothpaste tube, and all that clotted blood just kind of shoots out of you. It's very disturbing, very disturbing. I know that caught my husband by surprise because I didn't know what to expect with our first one. And he was like, oh, is that normal?
Does the skin to skin, I know you mentioned that it helps reduce the bleeding, but does it also help with the milk production?
So,
Does it just release the oxytocin in general, or?
So there's a different hormone that causes the milk production, and that's prolactin.
Oh yeah.
And it's going to take a couple of days for that milk production to kick in. The skin to skin is also, it's mostly at that point important for the baby who learns mother's smell and touch, because their eyesight isn't very good. So the touch and the smell is extremely, extremely important. That's why they want the skin to skin. It's basically soothing to the child.
I was told that was for breastfeeding.
So oxytocin is a hormone that is also released when, so it's about levels, okay? So gentle touch can also get oxytocin to be released, but oxytocin doesn't make the milk, prolactin does.
Okay.
So Kimberly, if we were all together in a classroom, I would have walked up to you because you asked the question, and I would have put my hand on your shoulder after asking you if it would be okay, of course. That gentle touch, me touching your shoulder, would make your hypothalamus release oxytocin. But clearly you wouldn't start having labor pains from that. And clearly you wouldn't start having breast milk expressed from your breasts if you.
God, I hope not.
Okay. But oxytocin is also responsible for bonding. So for example, when my kids would get very upset, I would put a hand on their shoulder or arm, and it would calm them down. When I have an argument with my husband, I tend to reach for his hand because that oxytocin can also soothe. It doesn't necessarily always cause pain. So it is important also for social bonding. Oxytocin can also bring great pleasure. It is also what causes the uterus to contract during orgasms, for example. Men release oxytocin as well, and they're not delivering babies. So oxytocin is important for them for ejaculation. It's all about the levels, how much of it. A little bit, there's bonding, there's orgasms ratchet up a lot more, then you start getting glands compressing for expressing breast milk and uterine contractions. So it's all about how much is being released in what time frame. Does that help? Does that make sense? Interesting?
Very
Not
interesting.
Yeah. Also, ladies, those of you who have had children and breastfed, I am sure you have had the experience of all of a sudden your breast milk lets down. And it usually was some sort of trigger that you associated with milk letting down. So for example, when I was breastfeeding, I had breastfeeding bras that had Velcro, right? Ladies, you had to have easy access. So I had Velcro so I could take down the flaps and easily nurse my babies. And the sound of the Velcro ripping became my trigger. I didn't know that until one day I was at a grocery store waiting in line, and the man in front of me had a Velcro wallet. And he opened his wallet, and I'm standing there, and next thing I know, I'm just through the bra and the pads, right? They give you pads, and I was just spewing out milk, just shooting it all over the conveyor belt where we put groceries. And I didn't know until this person was like trying to figure out where this moisture was, like he was being sprayed, and I'm just standing there and just not even aware. It was embarrassing. Anyway, so the hypothalamus is supposed to be getting these neuronal signals, but your brain can actually learn the cry of your baby, for example, or any baby's cry. Some women let down their milk when somebody else's baby is crying. There are ways for the hypothalamus to go, oh, right then, I should be releasing oxytocin. It's time to let down. It's weird to say that your mind can have a mind of its own. I know that sounds ridiculous, but it can. So more on oxytocin in just a moment. Let me go over our comparison and contrast of the nervous system versus endocrine. When we're talking about nervous system, we're talking about neurons, a cell type that releases a chemical signal into a synapse. For endocrine, we're talking about glands, which can be many different cell types, and they release chemical signals called hormones into the bloodstream. Neurons use also electrical impulses, action potentials, which leads to the release of neurotransmitters. Endocrine system, their hormones can be released in 3 ways: neural, humeral, and hormonal, which I will talk about more. Come here, Kaya. Come here. You can go outside. And then the neurotransmitter, like I said, is going into a synapse, but a hormone goes into the bloodstream and it can travel throughout the entire body, having many different target cells. For the nervous system, the target cell is just on the other side of the synaptic cleft. It's local. Hormones can be all throughout the body. And each of the target cells are going to respond according to their pre-programmed ways. So we can see general responses, and we can see very specific responses like the heart, you heard me say, will behave like the heart. Adipose tissue will respond like adipose tissue. Neurotransmitters are released within milliseconds. An action potential is roughly 1 millisecond and leads to neurotransmitter release. That is going to have almost immediate effects on the target cell. Hormones can take longer. The fastest working hormone is a steroid, and it takes 45 minutes for that to provoke changes in the target cell. That might not seem like it's very fast, but 45 minutes to change gene expression, transcription, translation, and change the physiology of a target cell, that is actually pretty fast. And some hormones can last days, months. Heck, you all, this is week 13. You all have had a lot of cortisol, which is a hormone surging through your body. And even when you're finished with me, when you're finished with anatomy, the cortisol, the stress hormone that I've made you release by causing all this stress with exams and studying, it's going to last for a while, a long while. You've heard of stress eating. Yeah, cortisol makes us eat more. And we can talk about stress and stress responses when I get to cortisol. I'm sure a lot of you will have questions about that, and I will answer them. A neuron fires quickly, releases neurotransmitter. It also stops quickly. Endocrine glands can keep releasing their hormones. And like I said, the hormones can have long-lasting effects beyond minutes, beyond days, in some cases, months. Exocrine glands. In Unit 4, we learn about the digestive system. What's the difference between endocrine and exocrine? Well, an exocrine gland is something that will release a substance that will ultimately reach the surface of the body. It's not released into the blood, it's released into a structure that has a lumen. So it's released into a duct. Digestive glands many of them are exocrine. They're going to release digestive enzymes into the lumen of your small intestine, and eventually those things reach the surface of your body. You defecate. So exocrine, they're going to be released into a structure that is lined by epithelium, either a duct like your intestines or the surface of your body like your skin, your epithelium. And there is direct communication with the gland to this lumen versus endocrine, again, released into the bloodstream, circulates throughout the body, and can have very distant targets. Just to highlight again, the 3 ways that hormones can be triggered for release. Humeral, you heard me and saw me, right? It's something in the blood that will trigger the release of the hormone. For example, when your blood sugar levels drop too low, your pancreas releases a hormone called glucagon, and it tells your liver to release more glucose into the bloodstream because your brain relies on glucose for fuel. When you eat a meal and your blood glucose levels go up, this triggers your pancreas to release insulin, which then tells many cells of your body to remove the glucose from the blood, bring it into the cells, and use it as fuel. So humeral, something in the blood being monitored, in this example, glucose. If the glucose levels gets too high, insulin's released to lower it. If your blood glucose levels get too low, glucagon is released to raise it. There is another example shown on this slide. There are tiny little glands shown here. Let me use a different color. I'll circle them in purple. Those are parathyroid glands, and I'll talk more about them. But these glands release parathyroid hormone. When your blood calcium levels get too low, parathyroid hormone is released to elevate them. When your calcium levels get too high, parathyroid hormone is not released, so the glands stop releasing it. Something in the blood, like an electrolyte, like calcium, or blood glucose levels, something in the blood triggers the release of a hormone. Neural, shown here in this picture, you're seeing a preganglionic sympathetic neuron, and it stimulates the adrenal medulla cells to release epinephrine. Remember, the adrenal medulla cells are really modified postganglionic neurons, and they dump epinephrine into the bloodstream. And that's what we mean by neural. Sometimes neurons dump their neurotransmitter straight into the bloodstream, and then that technically means it's no longer a neurotransmitter, it's a hormone. So epinephrine, norepinephrine are examples. Oxytocin is another one. And so is a hormone called ADH that I'll be telling you about, not today, but I will be telling you about it as I continue this lecture on another day. So let's start with an endocrine gland. Let's pick the hypothalamus. The hypothalamus is an almond, and it's above, it's superior to your pituitary. Can you all still hear me?
Yes.
Yes.
Okay. It just was too quiet, and I was wondering, is no one there? Because I have it so that I don't see your faces, so that I have more of my controls available to me. And I just thought, I feel like that Greek mythological figure that went into Hades to bring his lover back, and he couldn't look back to check on her. And if he did, she didn't get to escape. Anyway, I feel like that. So the hypothalamus is just above the posterior pituitary and anterior. Anterior is also called adenohypophysis, and the posterior is called the neurohypophysis. And the hypothalamus does release, it makes and releases hormones. Now, these hormones are either releasing hormones or inhibitory hormones. Releasing hormones give permission. Releasing hormones give permission to the pituitary to release its hormones, okay? Inhibitory hormones tell the pituitary, absolutely not. No way. You're not allowed to release your hormones. I'm telling you, no. Now is not a good time. So these hypothalamic hormones will, in their name, will tell you which hormone it's targeting in the pituitary. For example, I'll use this one, GHRH. The hypothalamus makes growth hormone. That's the G. H is hormone, releasing hormone. And that hypothalamic hormone is basically telling the pituitary, yes, release growth hormone. Now is a good time for this person to grow. But there are times when it's not okay for a child to grow. And the hypothalamus will then release something called growth hormone inhibitory hormone. So this would be called GHIH. And growth hormone inhibitory hormone is it would basically tell the pituitary gland to not release, and it has another name. So somatostatin Soma means body, state means stay. Somatostatin is another name for growth hormone inhibitory hormone. It's another name for it. So body stay, meaning don't grow. Well, you might be asking, when would it be not okay for a child to grow? Growing is actually considered to be a non-essential body function. I know that sounds weird, but for example, when a child is malnourished, when a child is under extreme psychological stress, being physically abused, emotionally abused, they're under so much stress that their body's releasing cortisol, and cortisol basically tells the brain, the hypothalamus, this is not a good time to grow. This child needs every resource just to get through this stress, through this abuse. It is not uncommon for children who are victims of abuse to have short stature. So that is an example of when growth is not okay. It takes a lot of resources to grow. It takes a lot of nutrients to grow. It takes a lot of energy to grow. And if you're under chronic severe stress, you need those resources to get through the stress, to survive, to see the next day. Then we can talk about growing. But right now, with this stress, absolutely not. Most of you are not lactating right now. And that's because your hypothalamus is releasing prolactin inhibitory hormone, also known as dopamine. So men, you are releasing PIH right now. Ladies, if you're not lactating, your brain, your hypothalamus is also releasing PIH. But hey guys, can you start lactating? Yes, men can lactate. Why? That's not normal. You're right, it's not normal. You can get a tumor in your brain that starts overproducing or just starts producing prolactin, releasing factor. And then that tells the pituitary to release prolactin and you start making breast milk. So that's weird, but it does happen. It's rare, but it does happen. GnRH, I'm just going to tell you what these abbreviations mean, but you're going to see them again. GnRH stands for gonadotropin releasing hormone. And again, in your book, you can find a handy dandy chart that tells you what these abbreviations are, tells you the full name, and what that hormone will do. In fact, it's part of your homework packet. TRH stands for thyrotropin releasing hormone. CRH stands for corticotropin releasing hormone. Some books call it CRF for corticotropin releasing factor. So those are all hypothalamic hormones. There are also some hypothalamic hormones that are stored in the posterior pituitary, and that's ADH and oxytocin. I don't have them listed here because they are stored in the posterior pituitary, but they are made by the hypothalamus. These hormones I have over here are made and released by the hypothalamus. Over here, made but not released from the hypothalamus. All right, we are at 3:50. So I am technically our discussion section stops at 3:50, and I still need to get your lab exam open. Finn, stop it. It's feeding time. I need to set the time limits for everyone still and make sure everything opens up correctly. So I'm going to say goodbye and finish getting your lab exam up and running.
Can I ask a quick question?
Yeah, hold on. It will be ready by 4:15, okay? Yes, Kimberly.
For when we were talking about prolactin and how men can actually lactate, can they only lactate if there's a tumor, or can they like actually stimulate breast milk? Like if like I could make myself relactate.
Yes, I
I don't
guess.
know why they would, but like if like a transgender, I'm guessing,
But-
like was what I mean.
Okay, so it won't just be something suckling on your breast. There also has to be the hypothalamus has to stop releasing prolactin inhibitory hormone. So it's not just so much making prolactin releasing hormone, you have to stop making that dopamine.
Okay.
And to stop that. So it's one thing to stimulate the sun is in my eyes. It's one thing there. It's one thing to get the releasing hormone, but you also need to stop the inhibitory. So the stimulation can get the releasing, but you have to outmatch the inhibitory. It's a quantity thing.
Is oxytocin why, like when you first start breastfeeding, you kind of get like kind of mad? Like, I don't know how to explain it.
It is definitely I think it's also because there's some underlying pain. It makes our uterus start contracting.
Mm-hmm.
It definitely affects our mood for sure.
Yeah, I felt like it affected my mood more than I felt it in my uterus.
It can. I mean, breastfeeding is hard work, and for a lot of women, it's not something they tolerate well, and they get kind of shamed into giving up. And I think it's because a lot of women don't understand how oxytocin affects. It's a mood changer. Oxytocin really is a mood changer. And just like some women get really bad PMS and others don't, right? That's also related to oxytocin. Go ahead.
Does that have to do with anything with like how much milk? Like some women produce a lot more milk than others, or is that more like diet?
No, well, that's prolactin, not oxytocin.
Yeah.
And
Sorry, I switched back.
so calorie intake is important. I always, whenever I have family members that are breastfeeding, I try and make sure that they get fed first, and they need to be hydrated as well. So if you don't have adequate nutrition, if you're not well hydrated, you're not going to make adequate amounts of high calorie breast milk. So I usually try and take the baby and I say, you go eat first and eat as much as you want. Baby and I are fine, but you need to go eat. And I'm constantly nagging them, where's your water bottle? You need to drink water, 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 water. And then stress can also impair breast milk production. Again, breast milk production is considered to be a non-essential bodily function for the woman. Of course, breast milk is very, nutrition is very necessary for the infant. But when it comes, if that woman is under a lot of stress, she will dry up quickly. Absolutely.
Mm-hmm.
Mm-hmm.
I was a cow.
Well, I'm sure La Leche would love you. I mean, we need women to donate breast milk.
I did.
That's very historical, to have a wet nurse, because some women either couldn't or were under too much stress or for whatever reason, or just wasn't enough. Maybe they just couldn't let down enough. Maybe they had blockage of their glands. Lots of reasons why a woman might not be able to produce adequate amounts of breast milk for her baby. And it should not be an opportunity to shame that mother. That is not what we do. And if a woman decides to not breastfeed, we do not shame. It is a lot of work. Breastfeeding is a lot of work, and it is a very, it's not always fun.
Just because it's natural doesn't mean it comes naturally easy.
Correct. Mm-hmm.
But it's always the right temperature and it's there with you all the time. So there's that too.
Yes.
Maisie likes hers cold, like ice chunks, because she still has frozen breast milk.
It's not, yeah, I like your comment, Kimberly, just because it's natural doesn't mean it comes naturally to everyone. It doesn't. And it's not as convenient as we think it is. There's even a lot of still social stigma against a woman breastfeeding in public. Even family members can feel awkward if a woman starts breastfeeding in public. It's not always convenient. It really isn't.
Not worth your sanity.
I mean, and then also the child can all of a sudden not be interested at all. When my son started being more mobile, as soon as they realized they can sit and turn their head and that my boob didn't go with them every time they turned their head, they lost interest. So my husband's saying, I don't lose interest in your breasts. That is not the same thing that I'm talking about, honey. Anyway, yeah, it is not for everyone. And it takes a lot of support too from the family members to help that woman also feel comfortable. It is not for everyone, and it is not necessarily easy.
I exclusively pumped after about a month because I kept getting mastitis, and I will never do that again.
That
was
is painful.
Full-time job.
Yeah, and you also learn how to kind of adjust yourself so that you feel it. I mean, it really, for the men out there, you can feel it draining from your armpit. It feels like you've got fluid draining from way back here because you've got some of these glands that go way back here, and you learn to move so that you're not crimping those ducts with your arm. And I don't know. And you know if you've emptied them or not. And if you don't, then they get infected. It's easy for the bacteria from the baby's mouth to travel retrograde through the ducts into those glands. And then it's a bacterial infection. It's painful. It's like you get these big red knots, these big red bumps on the side of your breasts or on the front of your breasts. And then you get antibiotics and the doctors tell you, you got to keep breastfeeding to clear that out. Oh my gosh, is it painful? Painful. Yeah, it's not easy. Okay, my sweets, I'm going to get your lab exam opened. I hope you do well. Oh, hey, I wanted to warn you because I was going through it and taking the exam myself. There are redundancies. So, for example, certain heart structures are tagged on the model and on the dissected heart. Certain structures are tagged on the eye model and the dissected eye. So do not second guess thinking you can't have the same structure tagged. You can, okay? So there are redundancies. Do not second guess yourself.
Thank you.
You're welcome. Kick ass, everyone.
Okay, thanks.
Just give me 15 minutes.